The second factoring method we will learn is called difference of squares. It only works with binomials, and in every binomial that can be factored this way, both the first term and the second term have to be squares. It is called difference of squares because the sign in the middle has to be a minus. If it's a plus, this method won't work. The way to do a difference of squares is very simple. You write two sets of brackets because your answer will be a pair of binomials. The square root of the first term goes in both first positions. The square root of the second term goes in both second positions. And you put one minus sign and one plus sign. It always works that way, so I will prove it by doing several more examples. Two sets of brackets for the binomials. The square root of 36a squared is 6a. The square root of 1 is 1. 1 minus sign, 1 plus sign. Here, the square root of x to the 4 is x squared. And the square root of y squared is y. 1 minus, 1 plus. Each of these can be verified by multiplying the two binomials together, and you will see that they equal the original question. Here, the square root of 4b squared is 2b. The square root of 9c squared is 3c. 1 minus, 1 plus. This one is very complicated looking, but it is a difference of squares because 16, 49, 9, and 25 are all squares. A squared, b to the 8, a to the 8, b squared, and c squared all have even numbered exponents, so they are squares. You write your brackets. Square root of 16 is 4. Square root of a squared is a. The square root of b to the 8 is b to the 4. And the square root of 49 is 7. So the first term's square root is 4ab to the 4 over 7. The square root of 9 is 3. Square root of a to the 8 is a to the 4. The square root of b squared is b. And the square root of 25 is 5. The square root of c squared is c. So you have 3 a to the 4 b over 5c in both second positions in the binomials. If you multiply these two together, though it may seem like a lot of trouble, you will get this original question as your answer. Finally, let's do one that's a little bit more tricky. It doesn't look tricky. You write your binomial brackets. The square root of x to the 8 is x to the 4. The square root of y to the 8 is y to the 4. 1 minus and 1 plus. The only thing that makes this tricky is that we have a difference of squares as one of our factors, so we have to keep going. We cannot factor this because it is a sum of squares, but the difference of squares can be factored in the same way that we're doing everything else. The x to the 4 plus y to the 4 has to be carried down into our answer. Square root of x squared, x to the 4 is x squared. Square root of y to the 4 is y squared. So you put x squared and y squared in these positions. 1 minus, 1 plus. We're still not finished. This is a difference of squares. X squared plus y squared is not factorable. It has to be carried down. X to the 4 plus y to the 4 is not factorable. It has to be carried down. The factors of x squared minus y squared, though, are x minus y, x plus y. We finally reached a stage where nothing is factorable, because although this is a difference, x and y are not squares. It's not a difference of squares. This method works for any binomial with a minus sign in the middle where both the first term and the last term are squares.